March 4, 1944, 28,000 feet above Berlin. The cockpit of the P-51 Mustang was a bubble of tense focus. The deep, throated rumble of the Rolls, Royce Merlin engine a constant, reassuring presence. Captain Don Gentile's eyes, however, kept flicking from the vast, postal sky outside to the single, unnerving instrument in front of him, the fuel gauge. The needle hovered at a level that, according to every Army Air Force manual, every engineering specification, and every sober calculation made back in England, should have been impossible. He was over Berlin, the heart of Nazi Germany, and his gauge read dangerously low. He had just led his flight of Mustangs through a swirling dogfight against a desperate Luftwaffe, sending 2 Messerschmitt Bf-109s spinning toward the city below. Now, the immediate threat was gone, but a more insidious one remained. The simple, unchangeable mathematics of distance and consumption. They had enough fuel to get here, to this precise point in the sky. But to get home, according to the experts, they didn't. 600 miles to the west lay the safety of England, a distance that, until very recently, was a sheer fantasy for a single engine fighter pilot. Every other pilot in his squadron was watching their own fuel gauges with the same growing dread. This mission, this deep penetration escort to the most heavily defended target in Europe, should have been suicide. Just 6 months earlier, it had been impossible. The problem was one of simple, brutal physics. American bombers, the mighty B-17 Flying Fortresses and B-24 Liberators, flying deep into Germany, were being systematically slaughtered. Without fighter escort, without protection, they fell from the German skies at catastrophic rates. Missions like the one to Schweinfurt on October 14, 1943, a day that would become known as Black Thursday, had proven that beyond any doubt. On that day, 2 91 B-17s had set out to destroy Germany's ball bearing production. The strategic logic was sound: destroy the ball bearings, cripple the vast German war machine. But the P-47 Thunderbolts that escorted them could only accompany them to the very edge of Germany before their internal fuel tanks ran dry, forcing them to turn back. What happened next was a massacre. Freed from the threat of American fighters, German interceptors, Messerschmitt Bf-109s and Focke-Wulf Fu-190s, attacked in relentless waves. They came from above, from below, head-on. They concentrated on individual bombers, attacking again and again until the massive aircraft exploded, broke apart, or spun down trailing fire. The mathematics of destruction were brutal. 60 B-17s were shot down. Over 600 American airmen were killed, wounded, or captured. Another 17 bombers were so badly damaged they were scrapped upon their limping return. The loss rate was 26%. Unsustainable. Catastrophic. If it continued, the entire 8th Air Force bomber fleet would be annihilated within months. Lieutenant Colonel Ben Lay, flying as an observer on that mission, later described the horror in his official report. They came in from 12 o'clock level, firing as they closed. When they passed, more fighters attacked from 6 o'clock. Without escort, we were helpless. I watched B-17s explode, break apart, spin down trailing fire. I counted 23 parachutes. Over 100 men didn't make it out. The Schweinfurt raid forced a brutal reckoning at the highest levels of command. Long-range bomber missions without fighter escort were tantamount to suicide. But the fighters simply didn't have the range to protect the bombers deep into Germany. The Air Force faced an impossible choice: stop the strategic bombing campaign, essentially conceding the air war to Germany, or continue losing bombers and cruise at a rate that would destroy the force before it could destroy the enemies. At 8th Air Force Headquarters in High Wycombe, England, staff officers calculated the grim numbers. If loss rates continued at 20 to 25%, they would run out of bombers before Germany ran out of fighters. General Ira Eker, commanding the 8th Air Force, sent an urgent, desperate cable to Washington. Without long-range fighter escort, the strategic bombing campaign cannot continue. Require immediate solution to fighter range limitation. Current situation untenable. The solution everyone wanted was simple on paper: build fighters with longer range. But in reality, it was an engineering nightmare. In November 1943, at Wright Field, Ohio, the Army Air Force's best and brightest aeronautical engineers gathered to solve the range problem. They faced fundamental physical laws that couldn't be ignored. Aircraft range depended on a simple equation: fuel capacity divided by fuel consumption. To double the range, you needed to either double the fuel capacity or halve the fuel consumption. Fuel consumption was already optimized. The Merlin engine in the P-51 was a masterpiece of efficiency. You couldn't make it significantly better. That left fuel capacity. The P-51 had internal tanks holding 269 gallons, at a cruise consumption of about 65 gallons per hour. That gave roughly 4 hours of flight time, enough to reach Western Germany and return. To reach Berlin required at least 6 hours. That meant carrying over 400 gallons, an additional 131 gallons, weighing over 800 pounds. The engineers' consensus was clear and unanimous. Adding that much fuel internally was impossible. The aircraft's structure couldn't support the weight. The center of gravity would shift dangerously, making the plane unstable. The additional weight would reduce climb rate, maneuverability, and top speed to an unacceptable degree. External fuel tanks were briefly discussed and immediately dismissed. Colonel Donald Putt, the Director of Research and Development, stated the official position. External tanks create excessive drag, reducing speed and maneuverability. They're vulnerable to enemy fire. They compromise the aircraft's structural integrity. They're simply not practical for combat operations. The meeting concluded with no viable solution. The engineering consensus was that the immutable laws of physics prevented American fighters from ever escorting bombers to Berlin. Meanwhile, in the mud and chill of an English airfield, a motorpool mechanic was about to prove them all wrong. November 22, 1943. Bodney Airfield, England. Technical Sergeant Benjamin Kelsey wasn't supposed to be solving strategic problems. His job was maintaining P-51 Mustangs for the 354th Fighter Group, changing oil, replacing spark plugs, patching bullet holes. He was a craftsman, not a designer. But Kelsey had a practical, probing mind and a habit of asking questions that annoyed his superiors. Why couldn't the fighters carry more fuel? Why did they have to turn back at the German border, leaving the bombers to their fate? Why were bomber crews dying? Because of a simple lack of gasoline. The official answer was always the same, delivered with a tone of finality. It's an engineering problem, Sergeant. The experts at Wright Field are working on it. Do your job. Kelsey did his job, meticulously and without complaint. And then, on his own time, fueled by a stubborn belief that there had to be a better way, he did something else. In a remote maintenance hangar, after hours, using scrap materials, salvaged parts and borrowed tools, Kelsey started building. He wasn't an engineer. He had no formal training in aerodynamics. He just had an idea that seemed blindingly obvious to him. If the plane can't carry more fuel inside, put it on the outside. He found a 75-gallon auxiliary fuel tank from a damaged P-47 Thunderbolt. The tank was designed to fit inside the fuselage of the larger fighter. Kelsey, with a welder's torch and a machinist's skill, began modifying it. He fabricated crude but strong metal brackets to attach it externally under the P-51's wing. He rigged up repurposed fuel lines and a simple mechanical release mechanism that would allow the pilot to jettison the heavy tank when it was empty or when enemy fighters appeared. His squadron commander, Major James Howard, discovered Kelsey's project entirely by accident. wandering into the hangar one evening and finding his sergeant surrounded by metal shavings and welding equipment. "What in God's name are you doing?" "Sergeant," Howard asked, his voice a mixture of anger and disbelief. Kelsey stood up, wiping grease from his hands. "Well, sir, if we hang this tank under the wing, the pilot gets an extra 75 gallons. That's maybe an extra hour and a half of flight time. Enough to go a lot deeper into Germany." Howard stared at the contraption. A bulky metal tank bolted haphazardly to the sleek, beautiful lines of the Mustang. It looked wrong, a blasphemy against aerodynamic purity. "That's the craziest thing I've ever heard," Howard said, shaking his head. "You can't just bolt a fuel tank to a fighter's wing. Have you considered the aerodynamics? The structural stress? What happens if it ruptures in flight? You'd be sitting on a flying bomb." Kelsey had answers for none of these valid, technical questions. He just looked at his commander with a quiet, unwavering certainty. "I don't know, sir. But it might work." Howard should have ordered him to stop immediately. He should have reprimanded him for unauthorized and dangerous modifications to government property. Instead, he looked from the sergeant's earnest face to the crude, promising tank, and made a decision that would change the course of the war. "All right," Howard said, a slow smile spreading across his face. "Let's test it." November 28, 1943. Bodney Airfield. Captain Jack Ilfrey volunteered to fly the test. Volunteered wasn't quite accurate. Major Howard had gathered his pilots and asked who wanted to fly a Mustang with an untested, mechanically crude, potentially explosive fuel tank bolted to the wing. Every pilot in the room suddenly found urgent maintenance tasks or paperwork that required their immediate attention. All except for Ilfrey, a pilot known for his cool nerve and slightly reckless streak. He walked out to the flight line, looked at Kelsey's contraption, and shrugged. "If it falls off, I'll jettison it. If it blows up, well, we die in combat anyway. Let's see if this thing works." The ground crew, under Kelsey's direction, filled the external tank with 75 gallons of high-octane aviation fuel. The tank hung beneath the port wing, an ugly, asymmetrical appendage on the graceful fighter. Ilfrey's pre-flight check was more thorough than usual. He tapped every bolt, checked every connection, inspected every weld. Then he climbed into the cockpit, gave Kelsey a thumbs up, and started the Merlin engine. The powerful roar echoed across the field. He taxied to the runway, the aircraft lumbering slightly with the unbalanced load. Then he pushed the throttle forward and accelerated into the English sky. The takeoff was normal. The tank stayed attached. So far, so good. Ilfrey climbed to 10,000 feet and began his tests. First, handling. How did the tank affect the Mustang's legendary agility? He tried gentle turns, then steeper banks, and finally a slow roll. The aircraft handled differently. To be sure, there was a slight pull to the left from the asymmetric weight, and it felt heavier, less responsive. But it was controllable. Next, fuel flow. He switched the fuel selector to the external tank. The Merlin engine continued its smooth, powerful rumble without a sputter. The fuel system, cobbled together from spare parts, was working. Then came the most critical test, the release mechanism. Flying over an unpopulated area, Ilfrey took a deep breath and pulled the emergency jettison handle. There was a loud clunk, and the tank fell away cleanly, tumbling end over end toward the patchwork English countryside below. The Mustang, suddenly free of the burden, leapt forward. Its handling instantly restored to its pristine state. Ilfrey brought the aircraft back to Bodney and landed. He climbed out of the cockpit, a wide grin on his face. His report to Major Howard was succinct and historic. "It works, sir. The tank stayed on during maneuvers. Fuel fed properly. It released when I pulled the handle. It actually works." Major Howard, immediately recognized the staggering implications. If a single 75-gallon external tank could give 90 extra minutes of flight time, what about bigger tanks? What about tanks under both wings? He sent an urgent, triumphant message to 8th Air Force Headquarters. Have successfully tested external fuel tank installation on P-51. Results positive. Request authorization for expanded testing and operational deployment. The response from headquarters was swift, bureaucratic, and negative. External fuel tank concept previously evaluated and rejected by Wright Field. Modifications to aircraft unauthorized. Cease testing immediately. Howard read the message, his jaw tightening. He crumpled the paper into a ball and tossed it into a corner. He turned to Kelsey, who was waiting anxiously. "Build more tanks, Sergeant," Howard said, his voice firm. "We're going to need them." The bureaucratic battle had begun. In December 1943, at 8th Air Force Headquarters in High Wycombe, General Ira Eaker learned that a fighter squadron was conducting unauthorized, dangerous modifications to its aircraft. His first instinct was to order court-martials. Major Howard was summoned to headquarters to explain why he had deliberately ignored a direct order. Howard's defense was simple, direct, and powerful. "With respect, sir," he began, standing stiffly in front of Eaker and his staff. "We're losing bombers and crews every day because our fighters can't escort them. This invention, built by one of my mechanics, solves that problem. Every day we don't use it, more of our boys die." Eaker's chief of staff, Brigadier General Frederick Castle, was less than impressed. "You're a squadron commander, major, not an engineer. Wright Field has the best aeronautical engineers in the world. If external tanks worked, they would have designed them. This is a jury-rigged death trap." Howard didn't back down. He pulled out Ilfrey's test flight report and laid it on the table. He showed them Kelsey's detailed drawings, his fuel consumption calculations, the projected range extensions. The staff officers remained unmoved, citing a litany of regulations and technical objections. The design hadn't been tested for structural integrity. It hadn't been evaluated for aerodynamic efficiency. It hadn't gone through the proper channels. General Eaker had been listening silently, his eyes fixed on Howard. Finally, he held up a hand, cutting off his chief of staff. He asked one simple, decisive question. "How much range does it add?" Howard didn't hesitate. "A 75-gallon tank adds approximately 90 minutes of flight time, sir. That's enough to escort bombers another 150 miles deeper into Germany." Eaker did the quick mental math. Current fighter escort ended at the German border. Add 150 miles. That would cover the bombers to the Ruhr industrial area, perhaps even to Frankfurt. He looked at Howard. "What about larger tanks?" Howard had anticipated the question. "If we scale up to 150-gallon tanks, sir, we could potentially reach Berlin and return." The room fell completely silent. Berlin. The ultimate target, the heart of Nazi Germany. It was over 600 miles from England, a distance that had been nothing but a pipe dream, an unreachable goal that had cost so many lives. Eaker made his decision. He would overrule his own staff, ignore Wright Field's objections, and bet on a multiple sergeant's crazy idea. "Overrule the objections," he said, his voice cutting through the silence. "Authorize immediate production of external fuel tanks. I want a squadron equipped and operational within 30 days. General Castle protested. "Sir, Wright Field should properly evaluate the design first. There are procedures." Eaker cut him off, his voice sharp. "Wright Field has had months to solve this problem. They failed. A motor pool sergeant solved it in 3 weeks with scrap metal. Get these tanks into production. Now." The rush to production was frantic. In January 1944, at the North American Aviation plant in Inglewood, California, engineers received the emergency orders to manufacture external fuel tanks for the P-51. The chief designer, Edgar Shemude, examined Kelsey's crude prototype, which had been hastily shipped from England. He held up the welded scrap metal and improvised brackets with a look of profound skepticism. "This is the design." The Army Air Force liaison, Colonel Mark Bradley, was blunt. "This is what works. Your job is to make it manufacturable at scale." Shemude's team worked around the clock for 72 hours, reverse engineering Kelsey's design. They refined the aerodynamics into a sleek, teardrop shape. They strengthened the attachment points with standardized, heavy-duty mounting brackets. They perfected a reliable mechanical release mechanism. The final design used pressed aluminum construction and was available in 75-gallon, 108-gallon, and the crucial 150-gallon versions. Production began immediately, 3 shifts a day, 7 days a week. The first production tanks rolled off the assembly line on January 15th. By the end of the month, North American was producing 200 tanks daily. Simultaneously, modification kits were manufactured and shipped to England to retrofit every P-51 with the necessary hardpoints. But production was only half the battle. A massive logistical operation swung into action. The tanks were shipped to England by cargo vessel and distributed to bomber bases. They were stored in dedicated facilities. For every mission, ground crews had to attach the tanks, fill them with fuel, and ensure a perfect connection to the aircraft's internal fuel system. The process added 30 precious minutes to pre-flight preparation, but those 30 minutes bought 3 extra hours of flight time. It was a trade every pilot was willing to make. January 21, 1944, Debden Airfield, England. The 354th Fighter Group was selected for the first operational combat mission using external fuel tanks. The target was Frankfurt, 280 miles from England, far beyond the previous maximum fighter escort range. 48 P-51s, each carrying a 108-gallon external tank, were lined up on the tarmac, their pilots conducting a final, nervous walk around. The pilots had mixed feelings about the new equipment. Captain Dwayne Beeson voiced what many were thinking. "We're going into combat with giant bombs strapped to our wings. If a German fighter hits these tanks, we're flying gasoline bombs." The briefing officer addressed the concern directly. "The tanks are self-sealing, just like your internal tanks. If they're hit, they'll likely leak, but they won't explode. And you can jettison them the moment you have contact. Don't be heroes with them on. Drop them and fight." The mission briefing was straightforward. Escort the B-17s to Frankfurt. Engage any German fighters that appeared. Return to base. What wasn't said, but hung in the air, was the unspoken risk. If the external tanks failed, if they didn't provide the promised range, the fighters would run out of fuel over hostile territory. The pilots would face a grim choice: bail out and become prisoners of war, or attempt a crash landing in enemy territory. This mission was either going to validate Sergeant Kelsey's crazy idea or prove the Wright Field engineers had been right all along. The formation took off at 0830 hours. 48 Mustangs, each carrying over 400 gallons of fuel, climbed into the cold, grey sky. As they crossed the English Channel, several pilots reported handling differences with the external tanks. The Mustang was slightly less maneuverable. Slightly slower, but it was manageable. They rendezvoused with the bomber stream over Belgium, a vast, sprawling armada of B-17s flying in tight combat boxes, heading east toward Germany. At the German border, the point where American fighters had always, without exception, been forced to turn back, the P-51s kept going. For the first time in the war, American fighters penetrated deep into German airspace. The Luftwaffe's response revealed their complete shock. German fighter controllers, monitoring the inbound bomber stream, had positioned their interceptors beyond the expected range of American escorts. When the P-51s appeared over Frankfurt, flying protectively alongside the bombers, the German pilots were caught completely off guard. The combat was brief but decisive. The 354th Fighter Group claimed 11 German fighters, destroyed with no American losses. But the real victory was not in the kill count, it was psychological. For the first time, American fighters had escorted bombers to a major German industrial target and brought them home safely. The external tanks had worked. Captain Beeson landed at Debden with fuel still in his internal tanks. His post-mission report was ebullient. The tanks performed flawlessly. We jettisoned them before engaging the Germans. The Mustang handled like a dream after release. This changes everything. He was right. It changed everything. The strategic shift was immediate and profound. By February 1944, General James Doolittle, who had replaced Eaker as commander of the 8th Air Force, ordered the aggressive expansion of external tank use. Every fighter group would be equipped. Every mission would utilize them. The new strategic goal was clear and devastating. Destroy the Luftwaffe by forcing them to fight under conditions where American fighters now held the advantage. External tanks enabled a revolutionary, new tactic. Fighters would escort the bombers to the target. Then, instead of turning immediately for home, they would break off and go down on the deck, hunting German fighters as they took off or landed, strafing airfields, and attacking any target of opportunity. They now had the fuel to hunt, to engage, and still return to England. German fighter pilots, accustomed to attacking bomber formations without interference, suddenly found themselves fighting for their lives from the moment the Americans crossed the coast. The first major test of this new doctrine came during Big Week, from February 20th to 25th, 1944. The 8th Air Force launched a massive, coordinated assault on the German aircraft industry. The numbers were staggering: 3 800 bomber sorties, 3 700 fighter sorties. Nearly all of the fighters were equipped with external tanks. The Luftwaffe rose in a desperate, furious defense. But American fighters with their extended range were everywhere. Over the targets, over German airfields, along the flight paths. In that single, brutal week, German fighter losses exceeded 250 aircraft. More critically, the Luftwaffe lost a huge number of its irreplaceable, experienced pilots. Major Johannes Steinhoff, a German ace with over 100 victories, described the shock in his post-war memoir. We expected the American fighters to turn back at the border as they always had. Instead, they stayed with the bombers all the way to the target. Then they came after Vess. They had the fuel to hunt us. We were no longer the hunters. We had become the hunted. The external fuel tank had fundamentally inverted the dynamics of the air war. And so, the stage was set for the ultimate test. March 4th, 1944. Debden Airfield. The mission everyone had been waiting for. The target: Berlin, 630 miles from England. The deepest fighter escort mission ever attempted. 60 4P-51s from the 354th and 357th Fighter Groups would escort the bombers to the German capital itself. Each Mustang carried 2 external tanks, a 150-gallon tank under each wing. This gave each fighter a total fuel load of 570 gallons, enough just barely for the round trip on paper. Captain Don Gentile, already an ace with 10 victories, was selected as a flight leader. He understood the mission's profound significance. If we can escort bombers to Berlin and back, he told his men, no target in Germany is safe. We win the air war. The pre-mission briefing was dominated by one topic: fuel management. Every single gallon mattered. Pilots were instructed to maintain a precise cruise speed, fly at the most fuel-efficient altitude, and avoid any unnecessary combat maneuvering. The briefing officer was brutally clear. If you get into an extended dogfight, You will not have the fuel to reach England. You will be a guest of the Third Reich for the duration. Choose your battles carefully. The mission launched at 0800 hours. The weather was poor, with thick cloud cover, but it was flyable. As they crossed the Dutch coast, the familiar tension set in. Gentile monitored his gauges obsessively. The Merlin was consuming fuel exactly as calculated. The external tanks were feeding properly. So far, everything was working. Over northern Germany, they rendezvoused with the bomber stream, 328 B-17s, a mighty force heading straight for the heart of the Reich. The German reaction was ferocious. The Luftwaffe, defending its capital, threw everything it had into the air. Messerschmitt Bf-109s, Foch, Wolf 091s, and even the new, terrifying jet-powered Messerschmitt Me-262s attacked in desperate, determined waves. The American fighters immediately jettisoned their now empty external tanks and engaged. The resulting dogfight over Berlin was a chaotic, sprawling melee. A three-dimensional battle involving hundreds of aircraft across 50 miles of smoke-streaked sky. Gentile, his focus absolute. Shot down 2 Messerschmitts in quick succession, bringing his total to 12 victories. But even in the heat of combat, a part of his mind was constantly tracking the fuel gauge, watching the needle sink with every minute of high power maneuvering. After 15 minutes of intense fighting, he made the difficult, disciplined decision. He called to his squadron. "We've escorted the bombers in. Our job is done. Time to go home. Disengage." The flight back was the most tense part of the mission. The calculations that had looked so good on paper in the briefing room were now being tested in the cold, hard reality of a German sky. They recrossed the Dutch coast with their fuel gauges dipping into the red. They crossed the English Channel. The White Cliffs a beautiful, heart-lifting sight, with low, fuel warning lights beginning to flicker on in cockpits. Captain Gentile landed at Debden with less than 15 gallons of fuel remaining. Barely enough for 5 more minutes of flight. But he had made it. They had all made it. Every single fighter that had started the mission returned to England. The mission to Berlin had proven, beyond any shadow of a doubt, that external fuel tanks had revolutionized aerial warfare. No target in Germany was beyond the reach of American fighter protection. The Luftwaffe's own war diary entry for March 4th recorded the devastating psychological impact. Enemy fighters appeared in strength over Berlin. This development indicates American fighters can now escort bombers anywhere over Reich territory. Previous tactical advantages have been negated. In the weeks and months that followed, the impact of this one simple innovation became increasingly clear. At Luftwaffe High Command in Berlin, Reichsmarschall Hermann Joe Ring was shown intelligence reports on the American external tanks. His response was characteristically dismissive. "This is a temporary measure. These tanks are vulnerable, inefficient. Our pilots will shoot them off their wings." General Adolf Galland, the pragmatic commander of the German fighter forces, knew better. The tanks work. Herr Reichsmarschall, he argued. American fighters now have what amounts to unlimited range over Germany. They drop the tanks before engaging, so they do not affect combat performance. We must adapt our tactics immediately. But adaptation was nearly impossible. The entire German defensive strategy had been built on the foundation of limited American fighter range. That foundation had now crumbled. The production of external tanks exploded. By April 1944, with the concept proven in the crucible of combat, multiple manufacturers were under contract. North American-built tanks for P-51s, Republic Aviation for P-47s, and Lockheed for P-38s. Combined production soon exceeded 3,000 external tanks per day. The design continued to evolve. The early, crude metal tanks gave way to the 150-gallon paper tank, so called because it was manufactured from compressed paper and plastic resin. It was lighter than metal, cheaper to produce, and utterly disposable after a single use. These paper tanks cost a mere 18 each. Compared to the cost of a 50 Zarosan fighter plane, or the life of a pilot, they were essentially free. Technical Sergeant Benjamin Kelsey, the man whose stubborn ingenuity had started it all, received a promotion to Master Sergeant and a formal commendation. The citation read, "For innovative thinking and technical excellence in developing the external fuel tank system for fighter aircraft, significantly contributing to Allied air superiority over Europe." But Kelsey remained at his motor pool job, maintaining fighters. When a war correspondent finally tracked him down and asked him about his revolutionary invention, he shrugged, genuinely bemused by the attention. "I just wanted our guys to have enough fuel to do their job and come home. Didn't think it was that big a deal." That not big a deal had, in fact, won the air war over Europe. The final statistics tell the story with cold, hard clarity. Between May 1944 and the end of the war in May 1945, American fighters flew 137,000 long-range escort missions, nearly all of them using external fuel tanks. German aircraft production facilities were systematically destroyed. Oil refineries were obliterated. Transportation networks were shattered. All of this was possible because bombers could now reach any target in Germany with a protective umbrella of fighters. Luftwaffe losses became catastrophic. In the final year of the war, Germany lost over 18th Zarosan aircraft, the vast majority to American fighters equipped with external tanks. The kill ratio favored the Americans by more than 6-1. For every American fighter lost, 6 German aircraft were destroyed. The human cost, viewed from the other side, was a human salvation. Bomber crews, who had once flown into a hail of steel, now flew with the reassuring sight of Mustangs and Thunderbolts, dancing protectively around them. Staff Sergeant Joseph Connolly, a B-17 waist gunner who flew 35 missions, later wrote, "For my first 10 missions, we were on our own after crossing into Germany. The German fighters would hit us constantly. We lost multiple aircraft every mission. It was a nightmare. For my last 25 missions, we had fighter escort the entire way. We still encountered Germans, but our fighters drove them off before they could do real damage. I probably wouldn't have survived 35 missions without those escorts." The numbers bear him out. Before long, range escorts became standard. Bomber loss rates averaged 8 to 10% per mission. Afterwards, they dropped to a sustainable 2 to 3%. For every 100 bombers on a mission, this meant 60 to 80 more men would come home. Over thousands of missions, this simple innovation saved tens of thousands of American lives. The legacy of the external fuel tank extends far beyond World War II. The concept of extending an aircraft's range by carrying additional fuel externally became a standard practice in air forces around the world. It is the direct ancestor of modern aerial refueling, the technology that allows military aircraft to operate globally, projecting power anywhere on the planet. The story itself is a timeless lesson in innovation. It demonstrates that breakthrough ideas often come from unexpected sources, from people who are close to the problem and unburdened by conventional wisdom. It shows that bureaucracy and established expertise can often be the greatest barriers to progress. And it proves that leadership, the willingness to back a good idea, even when it comes from the bottom and challenges the top, is the essential ingredient that turns a crazy idea in a maintenance hangar into a war-winning reality. On May 7, 1945, one day before the German surrender, Captain Don Gentile flew his final combat mission. The target was Prague, Czechoslovakia. His P-51 carried 2 150-gallon external tanks as a matter of routine, standard equipment that no one even commented on anymore. But as he flew over a dying Reich, He remembered the fear and uncertainty of that first mission to Berlin, the constant, gnawing worry over fuel. That terror had been transformed into routine confidence. American fighters could go anywhere, stay as long as needed, fight when necessary, and always have the fuel to return home. The simple aluminum and paper tanks hanging under his wings had been as responsible for his survival, and for the victory of the Allied air forces, as any other weapon, any other tactic, any other individual act of courage. The lesson endures. The next great breakthrough, the next innovation that changes the world, might not come from a research lab or a corporate boardroom. It might come from a mechanic, a technician, an ordinary person doing a practical job, who looks at an impossible problem and, unburdened by the knowledge that it can't be done, asks a simple, crazy question. What if we just try this?